Let's take a look at this example. What we're doing here is being asked the question, is the conjecture all products of a number with itself are greater than the original value, true or false? And if it's false, we need to give a counterexample. We're not sticking with just lots of the morning every single time. We're going to do a little bit of math here and there. So our example is looking at the statement. Essentially, our square is bigger than the original number. If you look at that statement, if you remind yourself what it means to be a square, what it means when you multiply a number by itself, it might make sense. So let's think inductively. And by thinking inductively, I mean, let's try some examples. Usually with this type of problem, not necessarily the best place to go, but a decent place to start is some guess and check. At the very least, it'll give you a better sense of what you're looking at, have some examples that you've worked with. So, try some numbers out. Let's say the number 2. There's a reason why I picked 2 that'll make sense in a second. Let me look at 2. Well, 2 times 2 equals 4. Not the most complicated math in the world. And more importantly, 2 times 2 is greater than 2 because 4 is greater than 2. Okay, a good sign for our idea. Looks like 1 square is bigger. Try another number. Let's try a bigger one. Let's try 5. Well, if you take 5 times 5, I don't know why I made the first one so small, but that's okay. You get 25. Which, hey, 25 is bigger than 5. It looks like our idea is going to hold some water. Let's try again. Let's try something a little bit bigger. Let's try 20. If you take 20 times 20, you would get, splitting that thing up into pieces, 2 times 2 times 10 times 10, so 4 times 100. 400, which is definitely bigger than 20. So, using a few examples, the idea looks true, but remember, when it comes to this idea of reasoning, when it comes to the logic we're working with, looking true isn't good enough. All that has to happen is it doesn't hold true once, and then we're sunk. Let's try a different number. Because we're looking for a counterexample. We're looking for a case where this doesn't work. What about 1? 17. Question mark got away from me. Okay, well, look at 1. 1, if you square it, you get 1 times 1. Nice thing about 1 is if you multiply 1 by something, you get itself. And you're multiplying itself by itself. You don't do very much. You'll just get 1. The 1 is not less than 1. Shocker, something's not less than itself. That's kind of a weird case. Might not be very convincing by itself, so let's try something maybe with a little bit more to it. Try a fraction. Try 1/3. Well, if you do 1/3 squared, you have 1/3 times 1/3. 1 times 1 on top is 1. and 3 times 3 on the bottom is 9, which, those of you who remember your fraction, is not actually bigger than 1/3. It is, and that's a very bad notation. It should be a colon, not an equal sign. Because this is actually less than 1/3. Because this is less than 1/3, we can say that this idea, our conjecture, is false. Again, when it comes to this thing, all we need for something to be false is one case where it is not true, unless you want to be very careful about your wording to avoid that one case. And here we weren't. In fact, this doesn't just have one case where it's not true, it actually has infinitely many of them. Anything between 0 and 1 will break that statement. It will cause that conjecture to fail. Here, got our counterexample. The conjecture has to be false.